Solving systems using substitution. When you see a system of equations and one of the equations is already solved for a variable, this is a sign that you should use substitution. Because what you can do is you can take this entire equation, 4x plus 11, and put it in to the first equation. And it makes it really easy to solve for one of your variables. And then you just plug that variable back into your first equation again, resolve again, and you get your set of answers. So here we have 3x minus y equals -7. That's our first equation. And in the second step here, they've put in 4x plus 11 for y. They substituted it in. That's where the substitution idea comes from. Then we take our 3x minus, and we distribute that negative sign into there. And we get 3x minus 4x minus 11. Then we combine our like terms, which is where the minus x minus 11 equals -7 comes in. So they did two steps in one. Then they add 11 to both sides. And we get -x equals 4, multiply by each side by -1 or divide by -1, either way. And you get positive x equals -4. Now that we have one of our variables, we have x, we put that back into the original equation, whichever one you want. Y equals 4x plus 11 is the easiest one to use. So we'll put our -4 in for x in there. 4 times -4 is -16. -16 plus 11 is -5. So we get the solution of -4, that's our x, comma, -5, that's our y. And we're going to make sure that we put that inside of parentheses because this is a coordinate. This is where the two lines for those equations cross. This is the exact point on the coordinate grid where those two line up. Here is a graph of those two equations. The 4x plus 11 is the kind of orangey red one. The 3x minus y equals -7 is the bluish teal one. And we can see that at the point -4, -5, they are crossing. That is where they intersect. How would the substitution process differ if the second equation were 4x minus y equals -11? Please take a moment to answer that in your notes and have the answer ready because you will see it later, this question again later, on your Canvas page. A common error that you will see, students will take their first equation, they'll substitute in their second equation, which is all great, and then they will just combine the like terms instead of distributing first. Remember that this entire thing, the 4x minus 11, that entire thing is your y. Not just the 4x, not just the 11. The entire thing is your y. So you have to distribute first before you can combine your like terms. And then when you do that, you get your answer of 18 instead of -4. When you plug that in, you get 83. So you get a point that is nowhere near where the intersection of those two lines actually meet up. So parentheses are huge when you're doing substitution. And then we have a video here for you. I'm going to close my screen right here, and I'm going to play this.
You can use algebra triads to help solve a system of equations by substitution. Start by solving one of the equations in the system for y. Substitute the expression for y into the other equation. Solve the resulting equation for x. Start by using algebra triads to solve the equation. Negative x times and isolate the positive x times on one side of the map. Equation by separating the trials at each side into equal groups. Substitute the value of x into either of the equations in the system and solve for y. Write the solution of the system as an overview.
And there you have another example within an example. Hope this helps. Let me know if you need anything.